we're going to talk about the mole. And no, the mole is not just a beauty mark or an underground rodent. It can be more than that. A mole can also be a unit of measurement. If I were to ask you, say, for a dozen candy bars, how many would you bring me? 12. And if I ask you for a mole of something, it's representing a number 2. Now that number, which I haven't shared with you yet, is way, way bigger than 12. Way, way bigger. And let me tell you why that number is so big before I even tell you what the number is, because I don't want to scare you off with such a big number when really the word mole is just so I don't have to keep telling you that number and writing it out over and over. But I'll write it out once just for you guys, okay? Here's my story. My story is that atoms are so tiny that this one little tiny dot here has over 1 million atoms in it. Take a look at a period in a book or a decimal point. There's over 1 million atoms inside that one little tiny point. So they're really small, right? Let's talk about the lightest atom that there is too. We have an atom here where all it has in hydrogen is 1 proton. It has a mass of 1 atomic mass unit that's just coming from our 1 proton. And really, those protons, in terms of grams, are just ridiculously tiny. So everything that we do when we're talking about chemicals and elements, we're talking about a really, really, really small scale. And my story that I have not verified in any way, shape, or form that helps me think about it is that scientists wanted to be able to take even this lightest atom, hydrogen, and get enough of it so it could make 1 gram on a scale. Now just to give you some perspective, a cent, a 1 penny, we measured those the other day in lab and we found out they only weigh about 2.5, maybe up to about 3.2 grams. So these are some small masses, especially if I were to ask you for 1/3 of that amount, for just 1 gram. But if scientists, let's say, wanted enough hydrogen atoms that each had just this 1 atomic mass unit, and they wanted to have enough of them that they could make the scale weigh 1 gram, here's how many they would need. They'd need 6022. But I'm not done, not just 6,000 atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, not done. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Let's see if I can even get that number in the whole screen. I don't know if I can. Look at that, it goes all the way down there. That's how many hydrogen atoms it would take to make a scale read 1 gram. A penny chopped into 3 parts. Now, I'm not the best at math, so I know that this place is 1,000, and if we go over another 3 places, we're at 1,000,000. So again, this is how many of those could be in 1 dot. But we keep going, and we should be up to 1,000,000,000,000, and then we'll keep going, and let's see. 100,000, million, billion. Oh, sorry. Now I'm up to trillion. Now I'm up to quadrillion. I don't know the next terms, so I'm even past. I make up the word gazillion. And one of these days I'll actually find out what comes after quadrillion. It's a lot. A lot of atoms. And if we condense that and we just were to write it in scientific notation, it would be a 6. And let's put those 0 to 2. Beyond that, I don't have any more significant figures. So I'm going to go ahead and put in my times 10, and I end up with 23 places after that decimal point. I'm going to multiply by 6 by 10 23 times. That number is equal, and anything of that number is equal to 1 mole. So you can imagine people did not want to have to keep writing out this number with all those zeros, and even a shortcut to saying 6.022 times 10 to the 23rd of anything, candy bars, cats, atoms, molecules, the way they were able to shorten that is just to give it a name of a mole. So just like a dozen represents the number 12, the word mole represents 6.022 times 10 to the 23rd anything, whatever you want it to be. Just like I can have a dozen of anything. Now later, since there was a scientist who worked really hard on things that had to be related to this, and so people wanted to give him some credit that they felt he was due, they've named this Avogadro's number. Yes, it can be funny if you think about it sounding a lot like avocado, but it's actually Avogadro, and they named it after him. So this number that represents 1 mole is 6.022 times 10 to the 23rd, can also be known as Avogadro's number. And I'm going to stop here and just make another video to keep talking about how we can use this number to do a lot of fun stuff.